everyone. It's so good to see you all back here at QA Online Academy. I'm Rachel, and I'm thrilled to continue our SQL journey together. Before we dive into today's exciting topic, I hope you've all had a chance to review our previous lessons. Mastery of those basics is key to becoming a database pro. Today, we're taking a massive step forward. We're moving from just querying data to actually building our own database structures. We're going to learn the essence of the CREATE Table statement, which is the foundation of any database design. In the world of relational databases, everything starts with a table. Without tables, we have nowhere to store our information. The CREATE Table statement is our primary tool for defining the structure of our data. It's where we decide what kind of information we want to keep, from customer names to complex transaction IDs. Understanding how to build these structures correctly is essential for any QA engineer or developer. Let's break down the basic syntax. It all starts with the keywords CREATE TABLE, followed by a name that clearly identifies what the table contains. This name is followed by parentheses, inside which we define our blueprint. We list our column names, specify the data type for each, like whether it's an integer or a string, and finally, we can add constraints. These constraints are rules that ensure our data remains valid and reliable, like making sure a field isn't left empty. To make this concrete, let's look at a practical example. We're going to create a table called Persons. This table will have 5 specific columns: a person ID to uniquely identify everyone, a last name, a first name, and then address and city fields. Each of these needs a specific data type and some rules. For example, our person ID should be an integer and serve as our primary key, meaning it's the unique identifier for every single row in that table. Take a look at this code. We've defined our persons table. Notice how we've specified int primary key for the person ID. This is crucial for data integrity. For the last name, we've used varchar 255, which allows for names up to 255 characters long. And we've added not null. This simple constraint tells the database that we absolutely must have a last name for every record. Our other fields like first name and address are also varchars, but they'll allow null values by default if we don't specify otherwise. Once we run this statement, our database is updated with the new structure. You can see it right here in the database navigator. We now have our persons table with all the correct columns and their associated data types. It's empty for now, but it's perfectly prepared to receive its first records. This is a huge milestone in your database journey. It's like building the framework for a house before you start moving in the furniture. Sometimes you don't want to start from scratch. SQL offers a brilliant shortcut, the CREATE Table As statement. This allows you to create a new table by copying the structure and even the data from an existing one. As you see here, we're creating a German customers table by selecting everything from our customers table where the country is Germany. It's an incredibly efficient way to partition data for testing or reporting without having to redefine every single column. Now it's your turn to get hands-on. I've prepared a little challenge for you. I want you to open PyCharm on your computer and write a statement to create a new table named Party. You'll need to include columns for name, city, department, age, gender, transport, food, and 2 different drink options. Pay close attention to the data types. Use chars and ints where appropriate. I'm going to give you 10 seconds to think about it and start typing. Ready? Go! Great effort! Whether you finished it or not, let's look at the solution together. This will help you verify your logic and see how all those columns come together into a single, cohesive statement. Seeing it line by line really helps solidify the structure in your mind. Here's the completed code for our party table. We've listed all our columns with their specified character lengths and integer types. Notice how we use the char type for fixed-length strings like gender or food categories. This is exactly how you'd build a comprehensive data structure for a real-world application. Practice this a few more times and it will become second nature to you. That brings our lesson on CREATE Table to a close. You've done a fantastic job today. Your next task is to join me in the next chapter, where we'll learn the Insert Into statement, how to actually fill these tables with data. In the meantime, please go back through our previous chapters and practice these statements on your own. It's the best way to build muscle memory. If you enjoyed this lesson, please join our community by subscribing to our YouTube and TikTok channels at QA Online Academy. We love hearing from you, so please leave your feedback in the comments. Happy coding, and I'll see you in the next lesson.